Good evening once more. Welcome to today's session. Today is our last session with regards to this um, beginner unit, which was a common unit across various disciplines. It was more of an informative unit. So, before we deep dive and look at what we are supposed to do today, I just want us to have a quick review of what we learned yesterday, and that was on modern data management um, practices. So maybe just a quick review. There's something or one thing that was very important. One was for us to know what, when we are talking about modern data management, what does it mean? So we saw that it is a way to that we saw that it is a way of managing the way data is collected, stored, protected, and processed to optimize operations and assist in decision making. So, in the modern data management is as a result of changing organizational needs, because the volume of data that is being generated and processed by these of many organizations continue to grow, and therefore it means that there's need to invest in modern data management approaches so that uh, an organization is able to adapt and as well as to optimize. Yes, we went further and said that organizations have existing data management frameworks and tools, but most of them are used in storage of traditional kind of data, and therefore there's need for that shift to ensure that uh, the way data is stored changes a bit in organizations. We went further and looked at some of the best practices to achieve modern data management. And we see that it is very important, first of all, to set your goals from the word go. You must know what you want to achieve as an organization. So that's the first thing that you need to look into. Then again, we say that you need to start simple and build up. Like, um, why we say it like that is that it is an investment on its own, in terms of infrastructure, in terms of human resource, and so on. And therefore, also given that maybe it is something new you are testing, you cannot as well invest a lot of resources at once. It needs to be implemented in phases. So you start first of all what is doable based on an immediate need that the organization needs before now you build up. Another one is we say that you need clear documentation. Documentation, the purpose is for continuity. You know, as we say that in an organization, people come and leave. So as people come and leave, there's need for documentation to ensure that there's continuity, proper records in the company, and so on. Then also we talked about data quality. We say that the modern data management platform should be designed in such a way that the data collection instruments are able to ensure that we minimize human error. And we didn't say that, for instance, like even if these designs are done at what level, they cannot, human errors will always be there. But as an organization, like there must be, I can say maybe the minimum acceptable a kind of error, maybe less than 1% and so on, based on internal organizational policies and so on, which of course change from organization to organization. Another one is what you call data quality. When you are talking about garbage in, garbage out. So uh, yeah, data quality, I think, is the same that I was talking about, minimizing that's human error. The next one was on audit trail. Audit trail, we say that like those modern data management platforms should allow you to be able to do some kind of an audit and understand what happens to your data over time. Like you keep track or records of what happens. And I gave a simple example of the tools that most of us already are using. Like for instance, Google Drive. When you upload a document, it gives a timestamp. When someone deletes it, the same thing happens. So um, it is very important. Again, we said there must be a balance between accessibility and security. Like, yes, we are putting internal controls as a company, but this data must be accessible to those people who need it for the purpose of doing the analysis and making decisions. Then the last one we talked about cyber security provisions for the system used. And I say that it is very important always to do some kind of system audits to ensure that they are not vulnerable to external attacks and so on. And then after that, we looked at the characteristics of modern data management. First of all, we say that they must be user-centric. What normally call those people in the product development, nowadays we have what we call user centricity when you are developing the product, for instance, whereby let us say it is the product that the company is developing that it should be consumed by external people. That means that you involve them in the journey. You don't just make assumptions in the boardroom, then go out and launch it. So user centricity with this regard specifically on modern data management, we say that it is very important that in an organization, those people that should lead the conversation are the business decision makers, not the IT team. Then we talked about security, that the information as digitization goes on, the information becomes vulnerable to attacks and of course leakage, data breaches and so on. Like in the past, when we didn't have like mobile banking and so on, whereby you used to go physical to the bank, the issues of SIM swaps and your maybe some kind of your money being uh, getting lost, it was very minimal, but nowadays it has increased because of the digitization. Also, we talked about cost optimization. It must be um, like you must not, the system you are investing in must not be very costly. Then we talked about centralization of the information, like your information should be kept in one place to avoid some kind of confusion and so on, whereby you get your data is all over. Then also we talked about cloud. Cloud, we talked about that you store your data so that your team or employees can be able to access anywhere at whatever time that they need. So, and this one we had a small discussion whereby we were looking at the banking sector, for instance. In the past, I think all the information they used to store locally, but we saw that from one of our colleagues who has first had experience in that sector, informed us that it depends with the regime. Like he gave an example, in Kenya currently, banks are implementing. In other jurisdictions, yes, they are used to They are also allowed to store data in the cloud, but the cloud infrastructure must be within the specific country or the jurisdiction. It should not be outside that country, and so on. So having looked at that yesterday, in case you missed it, that is what we were able to look into. So today, just want to some aspects. First of all, I want us to look at some of the programming languages that are used in data science and those that are related to data science. So if you know these programming languages, it enables you to come up with programs that execute specific operations. And the advantage of these languages, like Python, the first one is R. Then we have Python, the one with the yellow, the one with that's the yellow and blue is Python. Then we have MATLAB, the last one. So the beauty of a programming language is flexibility as compared to languages such as Excel, which one else, SPSS, and so on. And when you are talking about a programming language, because you are going to see there's a programming language, then there's a framework. You are going to see at frameworks. What a programming language does, it just assists you to, like helps you to build many things. If you are working with, you want to build a machine learning model that maybe does loan scoring, you want to build a machine learning model that detects diseases, you want to build a machine learning model that detects crop, like weather patterns and so on. So it gives you that flexibility. So a programming language helps you to build many things and it gives you the flexibility. So we have some like R, Python, and MATLAB, of course, combined with structured query language, SQL. They cover most of the tools used when working with both traditional data and conventional data science, business intelligence, and so on. But Python and R are the two most popular tools across data science subdisciplines. But R currently, what is happening, they are trying to, you see, R has a development environment called R Studio. In about such a time last year, it was in September or November there, of October, around such a time, they were able to change the name to POSIT. POSIT because what they were trying to do, when I read the CEO's reason why they are changing and so on, they were saying that they are also trying to make their tool more flexible and to have more capabilities as Python for data science and so on. So they were trying to rebuild it because R initially, it was designed as a statistical software for statistical tests and so on. Like when you have a hypothesis, the same way SPSS works, that was the initial origination. Before now, it kept on improving to be used for modern data science and so on. And remember, we said that data science has been there 25 years ago, but what has happened is just the methodologies and so on that has changed. So the two tools are the most popular across data science subdisciplines, and I hope you still remember the subdisciplines of data science, like data analyst, we have business intelligence, and so on. So the biggest advantage is that they can manipulate data, and of course they are integrated with multiple platforms and so on. Like for instance, you can link Python directly with these servers such as SQL server and so on. So you can even scrap your data in real time from the website and so on. That's the flexibility they have. So these also are very crucial, like for those people in mathematical and statistical computations. And the two tools are very adaptable to the organization existing infrastructure. Like you don't need to, if you want today to use R or Python in your company, you don't need to start purchasing other laptops, the IT infrastructure. They are very adaptable and straightforward. So, um, so when it comes to working with relational databases, um, structured query language SQL is one of the best, and because it was created for that purpose. So this one mostly when you are working with traditional historical data, especially when you want to do a business intelligence analysis and so on. It is a very crucial skill also to know. Then another one is MATLAB. MATLAB is for those people, especially when you are doing academia, you are doing your master's, PhD, and so on. MATLAB is a crucial tool, mostly when you want to deal with mathematical functions and manipulations. But mostly MATLAB is used in academia, like when you want to write your thesis or your project, whereby like an audit trail can be done. You see what normally happens in academia. If you analyze your data, for instance, in R, of course R has that functionality that can work as MATLAB, but when maybe you plot your graph in R, then you copy it and paste in a Word document, that compromises on the originality of your work in academia. So MATLAB gives you that capability to be able to do your entire project in one tool, so that it is easy even to follow up to confirm if your work is authentic or you have just copied from somewhere. So that one mostly is used in academia. And I'm not saying that the rest aren't also used in academia, but I have mentioned specifically that one. Then we have another software and frameworks. Now, when you are talking about a framework, as I have said, a software, a programming language, like because we started on programming languages, then we are talking about software and frameworks. So when you are talking about a software and framework, what they do, they can assist you to perform one purpose only. So, like it means when you're talking about software or software solutions, they are mostly adjusted for specific business needs. Like you want just to use it for a specific need in a business, that's what a software and frameworks assist you in. So, the most common, like you cannot be a data scientist or a data analyst if you don't know Excel. This is the most common and basic tool that is both used in traditional data, business intelligence, and data science. So Excel is a tool that it has become so powerful. Like if you have an updated version, in fact nowadays I saw they are even incorporating some Python and AI, artificial intelligence kind of tools in Excel, whereby it can, you just press, maybe you have your data set, you just click on analyze, then it is able to analyze for you without any or with minimal human intervention. So we have another one called SPSS, that's the Statistical Package for Social Sciences. This one is also very famous when you want to do statistical analysis, especially when you are conducting a survey. Maybe you have given a questionnaire and you have a hypothesis that you want to test. SPSS is crucial, like when maybe you are collecting data, you are asking people about age, if they like a certain product, and so on. It is mostly used for social sciences and research that involves administration of questionnaire and so on. Then there's another framework here called TensorFlow. This one is a library. A library is like a collection of tools. It's a library and framework that is designed for working with what we call big data and also designing machine learning algorithms. This TensorFlow, it was developed by Google, and the main purpose why they developed TensorFlow was for internal use, for big data analysis and machine learning. But later in 2015, they made it public, and it is a very crucial when working with neural networks, which is part of deep learning and so on. So it is a crucial one you will come across when you will be doing machine learning, the aspect of TensorFlow and how it is used and so on. Then another one, we have Apache Hadoop, HBase, and MongoDB. It is a type of a database. They are designed for working with big data. So when you will get into big data unit, you will be using Apache Hadoop and Spark for big data analysis. So it is a framework. So it means that, like, you can, in most cases when you will hit there, because you will have learned SQL before you do big data, it is almost related but not exactly, and you will still use Python, and you will just import the Apache Hadoop and HBase kind of a library. A library is a collection of tools, and it will run within Python but using a different syntax, like how you are retrieving data from big data from the database and so on. So that's why I say that it's a framework, like it is designed for a specific business purpose. Then we have another one, Power BI. We have SAS, QLink, and Tableau, and top-notch examples of those softwares designed for business intelligence visualizations. Like if you want to do data visualization, the most common is Tableau and Power BI. In fact, Tableau is more powerful as compared to Power BI in data visualization and so on. And also, these data visualization tools also can do some kind of machine learning nowadays, because especially when you are working with structured kind of data, or what I can call as traditional kind of data, they can do some kind of machine learning, such as clustering and so on. In terms of predictive analytics, we have another one called eViews. Those people who are working in econometric time series models. Time series, we saw that when you want to visualize something, like there is a time frame over a certain period of time, like we are talking about maybe the prices of commodities, how they are rising or dropping over a certain time frame and so on. There's another one called Stata. This one is almost the same as SPSS. It is used for academic, statistical, and econometric research, where you want to do some regression. Of course, the regression we are talking here is the traditional one that we looked at, the classical statistical methods when we looked at traditional machine learning and so on. We have cluster and factor analysis and so on. It can as well be used, but it has limitations because it does not have the capability of a programming language that gives you the flexibility to do what you want and so on. So you will learn most of this, you'll come across most of these tools, SQL, you will come across TensorFlow, you will come across Excel. In fact, the next unit on statistics, you will be taught using Excel. You will come across Tableau, that's up at Spark and so on, and Power BI as you proceed. Then one thing about these softwares and frameworks, like for instance, if you know how to use Tableau, it is very easy to adapt to Power BI, Hewlett, and so on, because it is just a drag and drop. The data visualization tools does not have so much technicalities as compared, for instance, to programming tools. But also with the kind of programming tools, you won't be doing the whole programming for software engineers. You'll be doing the programming for data science. Like for Python, you will be using libraries such as pandas and so on. So we have specific libraries that are used specifically for data science, analytics, and visualization. So it doesn't mean that you will learn the entire language even for software engineering and so on. You learn specifically the section of data science and analytics. So those are some of the tools that also you need to be aware as part of this introductory unit. So going forward, like when now you start on the practicals, which will start on Monday, because today, like the remaining days, you'll be given to digest whatever you have learned before you move to the next unit. So now we can have questions, and also you can share your experience with the introductory unit. I think on my side, I see that maybe at least you have learned something. It has given you a general knowledge overview of the scope of what you are going to learn going forward. But also I like to hear from you how the unit has been, what you have learned, or any questions that you have with regards to what we have learned so far. I want to start from Chanai. Yes, Chanai, I see your hand is up. Okay, maybe we can go. Melas can come first before Chanai.
Yes, Shalai can hear you.
Okay. Yes, Chanai, I can't hear you from my end. I don't know. Is it my internet or can someone hear Chanai? Okay. Let me check. Because there's someone who spoke and I heard. I don't know if Let me just check on that. There's someone who spoke and I heard. I don't know if I'm on mute. Let me just connect with I don't know why. Because I was hearing you at the beginning. Just a minute. Yeah, I can hear you now. Hello, I can hear you. No, I can hear Melas, but not Chanai.
Hello?
Yes, Melas, I can hear you clearly.
Let Chennai try again. I can hear you too, and I can hear also Chennai. Maybe he can try again.
Okay. Let me, first of all, Chanai, just sorry, let me join with my other account so that I can see if I can hear you.